नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्विशेट्टी, फैकल्टी ऑफ मेजरमेंट्स। मैं आप सब लोग को यहां स्वागत कर रहा हूं हमारा यूट्यूब का महा रिवीजन सेशन पर। जल्दी से जल्दी जान को बेटा, जितना लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं। अगर आपने इलेक्ट्रिकल बैकग्राउंड से है और इंस्ट्रूमेंटेशन बैकग्राउंड ही, जो भी बैकग्राउंड हो, इलेक्ट्रिकल और ईसी और इंस्ट्रूमेंटेशन, अगर आपने गेट पेपर लिख रहे, मेजरमेंट्स इज ऑल्सो वन सब्जेक्ट एंड आपको पता होना है दिस इज वन ऑफ द फाइनेस्ट एंड इजीएस्ट एंड फास्टेस्ट प्रिपरेशन सब्जेक्ट। ओके, सो मेरा आवाज क्लियर आ रहा है? एक बार मुझे कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो सब कुछ क्लियर या नहीं। अगर ऑडियो वीडियो कंफर्म है तो मैं जा रहा हूं। यस, परफेक्टली। चल, गुड इवनिंग टू वन एंड ऑल। सो जितने लोग लाइव में हैं मुझे कंफर्मेशन कर दीजिए बेटा। सो ये सेशन के लिए बहुत सारा बच्चे वेट कर रहे हैं, मुझे पता है ये। या यस सर, गुड इवनिंग। चलो स्टार्ट करेंगे सेशन को। एक बार आपका बैकग्राउंड प्लीज कंफर्म योर बैकग्राउंड, फ्रॉम वेयर आर यू, ऑल दोस थिंग्स। चलो, सो मेजरमेंट्स का सिलेबस ओवरव्यू करवाएंगे फर्स्ट। सो इफ यू सी द मेजरमेंट सिलेबस, so what are the division topics I am going to discuss here? So first I am going to cover from the error analysis. So let us start from the error analysis. After error analysis, so we'll go for the measuring instruments. We'll go for the measuring instruments. Error analysis, and we are going for the measuring instruments. Yes, error analysis ne start chestunnanu. Yes Sujata ji, good evening to one and all. Yes, measuring instruments. Then we'll go for the power measurement and energy measurements. Okay, so today I am going to discuss only the concepts. In tomorrow's class we'll discuss the problems. Okay, so these are the topics I am going to discuss: power and energy measurement. Okay, and the bridges also we are going to discuss. Is it fine? Everything is clear beta? So confirmation kar dijiye, everything is clear or not? Yeah, how your preparation is going on? Just confirm me, what is the level of your preparation? या आश्रिता अभी क्लियर है वॉइस? यस यस यस, अभी क्लियर आ रहा है देखो. So if you see the instrumental errors, in the instrumental errors we are having the loading effect error and misuses of instruments, inherent shortcomings of the instrument. These are also one important context. Okay. Yeah. Perfect. Perfectly coming now. Chalo, gross errors, systematic errors, random errors. So these are the instrumental errors. In the instrumental errors, we are having the loading effect, misuse of instruments, inherent shortcomings. Please have a theoretical context of errors because I have seen some of the questions. हमको क्वेश्चंस पूछ रहे एग्जाम में क्वेश्चंस पूछ रहे एरर एनालिसिस के ऊपर भी, लेकिन न्यूमेरिकल प्रॉब्लम्स हमको पता है कैसे सॉल्व करना, लेकिन समटाइम्स क्या होता है ना, थियोरेटिकल क्वेश्चंस भी आ रहे हैं. सो थियोरेटिकल क्वेश्चंस के लिए आप ये यूज कर सकते हैं पर्टिकुलर स्लाइड. ओके ना. चलो नाउ लेट अस हैव अ ग्लिम्स ऑफ व्हाट इज ग्रॉस एरर. ग्रॉस एरर बोलो तो क्या है, देखो जस्ट यू हैव एन आइडिया ऑफ ग्रॉस एरर. व्हाट इज ग्रॉस एरर? Gross error majorly contains what? Gross error majorly covers human mistakes. Okay, human mistakes will be considered as the gross error. Human mistakes in reading instruments and recording and calculating measurement. For example, अगर आपको specs use कर रहे, अगर आपने spectacles use कर रहे, अगर आपने you are using a spectacles or you are using something like specs. So then what happens now? Then what happens? You are going to have some oversight. Yes or not? So you will be having some oversight. See here. Due to oversight, the read of temperature 31.5 while the actual reading may be 21.5. That is a human mistake. That can be the human mistake, human understanding, human ability to see that. Okay. Next. Gross errors may be any amount and then their mathematical analysis is impossible. So it is actually not a mathematical error. अगर आपने कोई ना कोई calculation में कुछ कर रहे, it is not like a mathematical, it is just a human error. Okay. So these can be avoided by adopting this. First one is great care must be taken. Great care must be taken. Second thing, 2 to 3 or even more readings should be taken. So please have this theoretical information. Ashrita, Sujata, जो जितने लोग लाइव में देख रहे, so these are the topics which I have even not covered sometimes in the live classes, क्योंकि आजकल क्या हो रहा है ना, हमको न्यूमेरिकल सेशंस पर ज्यादा फोकस कर रहे हैं. समटाइम्स क्या आ रहा है मेजरमेंट्स में, इतना तगड़ा क्वेश्चंस नहीं आ रहा है मेजरमेंट्स में, इजी क्वेश्चंस आ रहे हैं. So at that time also you should be very careful about this. Okay. So ग्रेट केयर मस्ट बी टेकन इन रीडिंग द डाटा. अगर आपने कुछ ना डाटा रीड कर रहे, अगर एक के बाद 2 बार 3 बार उसको रीड करना है. सो दैट्स व्हाट हैपनिंग. सो सेकंड कम्स द सिस्टमैटिक एरर्स. Systematic errors are classified into 3 categories as I told: instrumental errors, environmental error, observational error. So systematic errors means due to system. As a name indicates, system बोलो तो यहाँ instrument है, system में कुछ fault है तो that fault will be reflected in the form of error. So those errors are instrumental errors, environmental errors and observational errors. So if you see the instrumental errors, these errors are what? These errors arise due to the 3 main reasons. One is due to the inherent shortcomings in the instrument. Shortcomings means what? Suppose आपने PMMC use कर रहे, PMMC में एक spring है, because of multiple times usage क्या होगा, वो spring का nature withheld होगा. So if the spring used in permanent magnet instrument becomes weak, permanent magnet instrument becomes weak, then the instrument will always read high. Instrument will always read high. Okay ना. So why? Because the spring contraction कम हो गया ना. अगर spring का contraction कम हो गया, क्या होगा, reading ज्यादा होगा. So if the spring constant is reducing, the TC will be reducing, whereas the deflection torque will be increasing. So the deflection force dominates, the deflection force gives like this. समझ में आपको? So please make a note. Ashrita, Sujata, these are untapped areas of measurements. मैंने अब तक ये एरर एनालिसिस पर इतना डिस्कशन मैं नहीं किया यूट्यूब पर, अभी कर रहा हूं आपके लिए. Note down, maintain the notes. ओके ओके, डेफिनेटली कर सकता हूं. सो नाउ इफ यू सी दी दिस इंस्ट्रूमेंटल एरर्स में एग्जांपल्स क्या क्या रहे देखो. ड्यू टू मिसयूज ऑफ द इंस्ट्रूमेंट्स, अगर इंस्ट्रूमेंट अगर मिसयूज कर रहे हैं आप, उसकी तरफ से भी आपको एरर आ जाएगा. नेक्स्ट, ड्यू टू लोडिंग इफेक्ट्स. लोडिंग इफेक्ट्स मींस वी एक्सपेक्ट द मीटर रेसिस्टेंस मस्ट बी इन्फिनिट, बट प्रैक्टिकली इन्फिनिट नहीं है, इसकी वजह से भी आएगा. नेक्स्ट कम्स एनवायरमेंटल एरर्स. Environmental errors are due to the external conditions like humidity, including conditions in the surrounding instruments. So they will be because of the temperature, because of the pressure, because of the humidity, dust, vibration. So that's how these errors will come. Okay. Chalo. Now, how these errors can be rectified? How these errors can be rectified? So next one is observational error. Other one is observational error, my dear. Observational error means because of the vision, because of the line of vision is not perfect. Okay, inaccurate estimate of average reading, wrong scale reading and wrong recording of the data, these are observation. So these all will come under the systematic errors. In the systematic errors we are getting all these things: instrumental errors, environmental error, observational. So I was talking about this. Gross error is because of human, systematic errors are because of the instruments, and the last one is very interesting, random errors. So ये random errors के लिए कोई reason नहीं है, आप जितने भी care लीजिए, however the care you have taken, the quantity being measured is affected by many happenings in the universe. You don't know that. The errors caused by happening or disturbances about which we are unaware are random errors. This is very interesting. You don't know this error is due to what. So, see, you may be thinking loading effect, you have resolved the problem. You may be thinking this is because of my sight problem, even though are resolved. Why? Because random error is happening randomly because of some universal reason. Something is happening in the space that may affect your instrument also. So that is what the random error. Okay, chalo beta. Now certain cases how these errors can be rectified. So to make the rectification of these errors, we have to do for statistical analysis. In statistical analysis you are going to take multiple readings. अगर multiple readings लेके उसको average करके वो average से भी आप निकाल सकते हैं. देखो first one, average deviation. Average deviation means what? जो भी आप ले रहे average, okay. See here, the average deviation is an indication of the precision of the instruments used in making the measurements. Okay. So अगर आपने average deviation is the sum of absolute values of the deviation. Suppose what is deviation 1? Deviation 1 is equal to measurement value 1 minus true value. अगर आपका true value 25 डिग्री सेल्सियस है, लेकिन अगर आपने कर रहे टेम्परेचर का मेजरमेंट बाय यूजिंग थर्मामीटर, यू आर गेटिंग 23.5, यू आर गेटिंग 22.6, यू आर गेटिंग 23.5, यू आर गेटिंग 24.5, यू आर गेटिंग 24.7 लाइक दिस. सो 1 2 3 4 5. समझ में आपको? So now you have to take the deviation. So the deviation 1 is 23.5 minus 25. Deviation 2 is 22.6 minus 25. 23.5 minus 25. 24.5 minus 25. 24.7 minus 25. Got it, my dear? So like that you have to take the deviations, and those deviations you have to take average. So from those deviations you are going to take the average, मेरे दोस्तों. Got it? So from those deviations you are going to get the average. So this is D1, D2, D3, D4 by N. So average deviation is the sum of the absolute values of the deviation. So deviation 1 I have given. So deviation 1 कितना होगा? Can you calculate for this? Deviation 1 is 23.5 minus 25. I am taking the mod. Remember this. This is one method. to calculate the standard average deviation. Next comes the standard deviation. In standard deviation जो भी हमको deviations आ रहे हैं ना, वो deviation का root mean square लेना है, root over d1 square plus d2 square plus dt square up to dn square by n. So by definition, the standard deviation sigma of an infinite number of data is square root of the sum of all individual deviations squared divided by the number of readings. So this is the number of readings. Okay, this is the number of readings. Suppose if it is greater than 20, so this is the formula. If it is less than 20, we can take this the formula n minus 1. N is a finite number. Okay, chalo. Next comes the variance. Variance is the square root of mean square deviation. That means sigma. It is a mean square deviation of that sigma square. Sorry, it is the square of the sigma. So जो भी हमको sigma आ रहा है, so that is sigma. So sigma square if you do, we are going to get the V. So variance is also one method. So what are the different methodologies we are going to do? Average deviation. Average deviation is one technique. Average deviation is one technique. Standard deviation is one technique, and variance is another technique. So please remember, this is an extra topic I want to touch for the especially for instrumentation students also, क्योंकि error analysis में कोई untapped areas रहे तो यही है. अब तक जो topics पर error analysis पर questions आए हमने discuss कर दिया already. I have discussed the sum of quantities, I have discussed the division of quantities. उसके ऊपर हमने problems भी करवाया था. But ये topic अलग है. So this is what we call as average deviation. So please note down, this is called the average deviation. This is what we call as standard deviation. This is what we call as variance. Okay, so please remember those formulas. Average deviation का formula क्या है? Average deviation का formula होगा ये होगा. Average deviation का formula, this I can take it as d1 plus d2 plus so on so forth dn divided by n, and sigma क्या होगा? Square root of, this is the formula, all the deviation sum you have to take sigma di square by n. So this is sigma d square by n, and v is equal to, so this is a sigma formula, v is equal to sigma square. Please make a note, this is an untapped area, please maintain the notes. Noted? Have you noted? Yes. Now this is one area. Now let us go for another one. See this, relative static error and percentage of static error. So when you are taking the relative static error, we can take the ratio of absolute error to the true value. That is what we call as relative error. So what is this absolute error? So we can take the measurement value minus true value by true value. So this is what we call as relative error. Okay. So this is what we call as relative error. And we are taking the percentage of relative error. So we can take measurement value minus true value by true value into 100. Please note down, this is another formula. Two formulas. Relative error ka formula percent. Sir, ee notes saripotunda sir lekunte inka theory chadavala sir. Ee saripotundi. Ee saripotundamma. You need ga notes maintain chesko. And already meeku problems, list of problems unnai gatamlo. You already discussed so many problems. So please maintain these notes properly. Measurement value minus true value by true value into 100. So that is the relative error. Noted? Simple. Whatever the box I am writing, you note it down. Chalo. Now let us go for this one. What is the guaranteed accuracy error? Guaranteed accuracy error, in short, what we call it as percentage of guaranteed accuracy error. Percentage of guaranteed accuracy error. Okay. So when accuracy is expressed in terms of error, it is called percentage guaranteed. Always remember, this guaranteed accuracy error is always expressed with respect to full scale value. First point. Second point, it is given by the manufacturer. Third point, ये हमेशा constant रहता है. So it is called a constant error for meter. It is fixed by the manufacturer. See the points. Point number 1. ये point क्या है? It is fixed by the manufacturer. It is called as a constant error for the meter. Percentage of guaranteed accuracy expressed with respect to full scale deflection of the meter. Full scale deflection of the meter. So this is what we call as percentage of guaranteed accuracy error. Got it? Done. Chalo. Now let us go for limiting error. So for example, I will tell you, I will give an example. Suppose if you are taking 0 to 150 volts, 0 to 150 volts, this is a full scale value. So in this, I am having 2% of guaranteed accuracy error. Okay. So percentage of guaranteed accuracy error is what? That is 2 by 100 of 150. 2 by 100 of 150. Then what happens? This one, this 0 gets cancelled. 30 by 10. So this is 3. So that will become 150 plus or minus 3. So this is what we call as percentage of guaranteed accuracy error. Understood? And always remember, it is expressed with respect to full scale value. It is always expressed with respect to full scale value only. ये हमेशा constant रहता है and it is given by the manufacturer. ये हमेशा किसके लिए देते हैं? Manufacturer देते हैं. चल. Next, अगर हमने error with respect to not full scale value but with respect to some limited value, if you want to express, if you are expecting this value with respect to a limited value, then उसको हम बोलते हैं limiting error बोलते हैं. So ये होगा हमारा limiting error. Limiting error बोलो तो क्या है? देखो, limiting error. Limiting error is defined as the deviation either in positive side or negative side in the measurement by instrument for a nominal value. That is a limited value. See, for example, see here. I will explain with a see. This is my 0 to 150 volts. The guaranteed accuracy error is 2%. So this is the guaranteed accuracy error, which is always given with respect to full scale value, which is constant and given by the manufacturer. Done. So now what happens? Now I want to know what is the limiting error with respect to 80 volts. So if we want to calculate for a measurement of okay 80 volts, the limiting error is how much? So first of all, in this previous problem, what is the percentage of guarantee accuracy error? Percentage of guarantee accuracy error is given as 2% of 150 volts. So that becomes as 2 by 100 into 150. So that becomes 3. Now percentage of limiting error for the measurement of 80 volts, that is 3 by 80 into 100. Expressing the error with respect to your limited value, कितना आएगा? 3 by 80 into 100 बोलो तो 300 by 80. 300 by 80. So that comes around 3.75%. Suppose if I am going for different extents, percentage of limiting error for a measurement of 100 volts, then what will be the answer? Or if I want percentage of limiting error for 10, what will be the answer? And percentage of limiting error for 150, what will be the answer? Can you tell me here? Please tell it. Yes, Chinmayavani. Done. So here कितना होगा ये ध्यान से देखो. How much we are going to get here? See here. For 100, how much it is going to come? So that is going to become as 100. You are expressing limiting error. You are expressing this error. What is the guarantee? This error is there na absolute error. So that is called absolute error. So that's what he has mentioned here. See here. Percentage of limiting error means expressing that with respect to your measurement. Okay, it's a variable error. So expressing that error 3 by 100 into 100. So that becomes as 3%. But when going for 10, we are expressing that with respect to 10 into 100. So it is going to become as how much? 30%. See this. If you are going for 150, expressing with respect to 150 into 100, so it becomes as 2%. So percentage of limiting error, if you observe closely, what is happening? The percentage of limiting error, if you see closely, the percentage of limiting error, this is 0, this is 150 volts, this is plus or minus 2%, this is a guaranteed accuracy error. Now At 80 volts, you are having plus or minus 3.75%. Next, at 100 volts, you are having 3%. At 100 volts, you are having 3%. Next, at 3 volts, you are having 30%. At 3 volts, you are having the 30%. 3 volts, you are having the 30%. So 30%, 3.75, 3% and 2%. So what is happening? Percentage of limiting error is decreasing towards full scale value. Am I right or not? Why? Because 30%, 3.7%, 3%. Next, percentage of limiting error is increasing away from full scale value. If you are going away from the full scale value, see it is very, very away, 30%. Now, percentage of limiting error is equal to percentage of guaranteed accuracy error. Why? Because if we want to measure by using this instrument the full scale value 150 volts, so expressing the error with respect to full scale value 3 by 150 to 100, 2%. So percentage of limiting error is equal to percentage of guaranteed accuracy error at full scale value. Please make a note of these values. So these are the things you must be clear. Make it fast. Excellent. टेन हाँ, कहाँ 10 होगा? कहाँ 10 होगा? अच्छा 3 का 10 हो गया. Sorry. 3 by 100, 30%. Okay, sorry. It's a mistake I have done. This is 3 expressing 10 into 100. 30 हो गया ना with respect to 10 volts. Yeah. अच्छा. Okay, done. At 10 volts measurement is 30%. At 80 volts measurement is 3.7%. At 100 volts measurement it is 3%. Okay, done. So at 150 volts it is 2%. At 150 volts it is how much? 2%. Done. Okay, Prashant, thank you. Chal. Now let us move for next. Now let us start the basic instruments. In basic instruments, if you see, we're having majorly measuring instruments. Basic instruments flow. What are the basic instruments we are going to get? Majorly, the basic instruments, what actually we are going to get, see here. What are the basic instruments we are going to get? PMMC we are going to get. Moving iron we are going to get. Dynamometer we are going to get. Wattmeter we are going to get. Energy meter we are going to get. And sometimes special instruments also we are going to. So these are the major measuring instruments. In this, the first one will be the PMMC. Very, very important. Next comes moving iron. Next comes dynamometer. Next comes energy meter. Okay, so major instruments, dynamometer. Next comes the wattmeter. Next comes the energy meter. Okay, so these are the famous instruments. Accuracy precision గురించి చెప్పాలా? చెప్తా. See, what is accuracy? If you are asking about accuracy, I will tell that also. Accuracy means closeness to the true value. Accuracy means what? Accuracy means it is closeness to the true value. Closeness to the true value. This accuracy is expressed always with respect to two values. One is the percentage of guaranteed accuracy error. Other one is a percentage of limiting error. So through these two techniques it is going to be expressed. Percentage of guaranteed accuracy error, percentage of limiting error. But what is precision? Precision is different, my dear. So precision is called as, what is precision? Precision is defined as, it is a measure of repeatability. It is the measure of repeatability. Is a measure of repeatability. Suppose the true value is 5 volts, but you are getting the values as 4.5, 4.52, 4.499, 4.512, 4.555. This is called precision. It is accurate and precision. Suppose you are getting like this: 2.1, 3.1, 4.5, 5.2. This is neither accurate nor precision. If you see 3.5, 3.45, 3.49, 3.499 and 3.501, this is precise. So this is the true value. So this is accuracy wise it is best, precision wise also it is best. Now if you see this, this is neither accurate, accuracy is poor, precision is also poor. But if you check this, this is accuracy is poor but precision is good. Try to understand this. Okay Ashrita, okay. अंदर का अर्थमవుతుంది, समझ में आ रहा आपको पूरा? जिन्होंने वो कुछ पूछ रहे तेलुगु में पूछ रहे, सर मुझे एक्यूरेसी प्रश्न के बारे में बताओ, पूछ रहे, इसलिए मैं पूछा. यस, अंते 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 सुजाता. Well, now if you see, they're asking what is resolution. They're asking some basic questions, and let me explain that. So what is resolution? So resolution को कैसे डिफाइन कर सकते हैं? देखो resolution को हम कैसे डिफाइन कर सकते हैं? Resolution is defined as, how to define the resolution? It is the minimum increment. It is the minimum increment in input which can modify already available non-zero output. What we can say is, we can say as it is a minimum increment that can be detectable by the meter. So threshold is different, resolution is different. Threshold bolte what is the minimum input to be given so that there is a live starts. Okay, so resolution of a ADC or resolution of a voltmeter, let us see, suppose there is a voltmeter like this. So if I am taking 0 to 5 volts is a voltmeter, or 0 to some 20 volts is a voltmeter. Okay, so 0 to 20 volts. So this 20 volts is divisible into 100 divisions. 100 divisions. So 100 divisions contribute as 20 volts. Then one division will be contributed as how much? 2 by 20 by 100, that is 0.2 volts. So this is one division. Now check, this is one division. So this is one division, this is the next division, this is the next division, this is the next division. So like that it goes on. How many divisions? 100 divisions are there. So one division contributes 0.2 volt. Now question, suppose if I am mentioning 1/5 of a division is the minimum readability. 1/5 of a division is the minimum readability. अभी क्या होगा? That will become 1/5 into 0.2. So that will become as 2/50. 2/50 बोलो तो क्या है? This is 2/5. 2/5 means how much? 0.4. So that becomes 0.04. So we can say now 0.04 is the minimum resolution. It's the minimum reading that you can detect. So this 0.04 volts is called as resolution. 0.04 volts को हम क्या बोलते हैं? इसको हम resolution बोलते हैं. 0.04 volts को हम resolution बोल सकते हैं. गुड इवनिंग. ईशानावस्थी, कहां से हो ईशानावस्थी? यस. नमस्ते नमस्ते. उत्तर प्रदेश, कानपुर. Okay, okay. Similarly, suppose if I am taking one ADC. Suppose if I am taking ADC, this is my ADC, analog to digital converter. So this is my V reference. So this is my analog input. So these are the digital outputs. Suppose let us take 1, 2, 3, 4, 5, 6, 7, 8. So this is D0 to D7. So this is D1, D2, D3, D4, D5, D6, D7. So this is the V reference. The V reference I'm taking as 5 volts, and this is the analog input. So what is the resolution of ADC in digital? In digital, resolution of ADC is given as V reference by 2 power n minus 1. This is also electronics oriented question. V reference I can take it as 5 volts, 2 power n. N is the number of digital bits, that is 8 by 1 minus 1. So I'm going to get 5 by 255. 5 by 255 means how much? 5 by 255. Kitna aa raha hai? So what is the meaning of that? Can you tell me what is the meaning of this 5 by 255? So I'm getting 5 by 252. Sujata, how much it's coming? 19 point. So it is coming as 19.6 millivolts. What does it mean? With respect to ADC, 19.6 millivolts is answer, but what does it mean? Can anybody tell me? 19.6 millivolts reflects what? Chalo. What do you mean by 19.6? Okay. What do you mean by, if we give 19.6 the input, we get different output? No. It doesn't mean that. See, if I'm giving 0 volts on the digital output, I'm going to get all zeros. If I'm giving 5 volts, I'm going to get all ones. Now for an increment of 19.6 millivolts, then there is a least significant bit is going to be changed by 1 bit. So that is what the resolution. Resolution of ADC means it is a minimum increment in analog input that should be given. क्या वॉइस नहीं आ रहे? आ रहे ना वॉइस? वॉइस तो बढ़िया आ रहे हैं. आप ही बोल रहे वॉइस नहीं आ रहा बोल के. वॉइस क्लियरली आ रहा है. So it is a minimum increment in analog input to be given. Minimum increment in analog input to be given so that there is a change in the least significant bit. That is what we call ADC resolution. क्या आ रहा है? वॉइस नहीं आ रहे? सुजाता वॉइस नहीं आ रहे? शिवमन सोनी वॉइस नहीं आ रहे? क्या हो गया वॉइस को? Is my voice is not coming, my dear? आ रहे हैं ना? अरे प्रशांत यादव आपको नहीं आ रहे? Yeah, that is the smallest change. So 19.6 millivolts, the smallest increment, the minimum increment in analog input to be given so that there will be a modification in digital output. जितना स्मॉलेस्ट इंक्रीमेंट आप दे सकते हैं इनपुट में उतना से उतना मॉडिफिकेशन हो सकता है. मिनिमम मॉडिफिकेशन को हम बोलते हैं ना. ओके ना? या ओके, थैंक यू. चलो, दिस इज व्हाट वी कॉल रिजोल्यूशन. प्लीज नोट डाउन द डेफिनेशन ऑफ रिजोल्यूशन. वी वांट यू कैन नोट डाउन द डेफिनेशन ऑफ रिजोल्यूशन. सो बच्चा पूछ रहे हैं मुझे. सो रिजोल्यूशन ऑफ एडीसी, resolution of ADC, resolution of ADC, the minimum increment the minimum increment in analog input to be given, in analog input to be given, the minimum increment in analog input to be given per ADC, so that the least significant bit of digital output will be modified, changes. Please note down, that is what the resolution. Thank you. Chalo. Done. There are different questions. Now I am talking about the basic instruments. First comes the PMMC. Please make a note, this is a permanent magnet moving coil. If you see the permanent magnet moving coil, as the name indicates, PMMC, this is having two parts. In PMMC, what are the major things? I am going for now fixed measuring instruments. First PMMC I am talking. The fixed part is the permanent magnet and moving coil is the moving part. So there are two parts. One is the fixed part, other one is the moving part. So the fixed part is this particular permanent magnet. So from this permanent magnet, we are going to get permanent magnet, which is the strongest magnet. So from that the magnetic flux density coming. Sir, mostly expected question from aeronautics చెప్పండి సార్, రీసెంట్ ట్రెండ్స్ మీద చెప్తాను. ఈరోజు మనం రివిజన్ చేస్తున్నాం, రేపు మహా అభ్యాస్. మహా రివిజన్లో, in Maha Revision we are discussing all the concepts. In Maha Abhyas we'll do some questions. So now if you see this permanent magnet, so from north pole to south pole the magnetic field is coming. So this is the B. Okay, so next these are the springs. Okay, so this is a scale. So here comes certain important formulas. So what are the formulas? Please note down. The formulas are, the first important formula for the PMMC here is the deflection torque formula. So note karo, formulas note hona hai. Deflection torque formula is BINA, BINA, and controlling formula is Kc theta, Kc theta. Okay, so B is the magnetic flux density, I is the current, N is the number of turns, A is the area of. So please remember this. What is the B? B is the magnetic flux density, the magnetic flux density of the PMMC. Listen carefully, ज़्यादा मत सोचना, ज़्यादा मत पूछना, जो मैं पूछ रहा हूँ, जो मैं बोल रहा हूँ, उसको आंसर कर लो. So इसका यूनिट्स है B is equal to 5/A, which can be called as Weber per meter square, which is also called as Tesla. Next, I is the current to be find out, which is the current, DC current passing. So this is a current question mark. N is the number of turns of the copper, number of turns. Next, A is the area of the coil. So BINA हो गया. K is the spring constant. K is called spring constant. So see here, deflection torque BINA, controlling torque Kc theta. So at steady state what happens? At steady state if you see the deflection torque is equal to controlling torque होगा. So I can take bina is equal to kc theta I can take. So from this I can take VNA by kc into I. If you take the theta is coming proportional to current. So always remember PMMC comes only for DC measurement. The scale is always uniform. We are going to get a uniform scale like this. Noted my dear students. So uniform scale है ये. This is a uniform scale. Please make a note of these points. It cannot measure for used in aeroplane. So advantage देखो कहाँ use करते हैं, aeroplane में use करते हैं, एरोस्पेस इंडस्ट्री में भी यूज कर सकते हैं. 0 Hz frequency uniform scale. 0 Hz frequency means Arshita it is suitable for Ashrita DC measurements only. DC measurement only. Please make a note. Done? Chalo. Now, next topic is PMMC ammeter. So इसके ऊपर भी क्वेश्चंस बहुत सारा आ सकता है. So PMMC ammeter का एक्सप्रेशन क्या होगा? PMMC ammeter range extension also very very important. So इसके लिए मैं ले सकता हूँ ऐसा. So this is the PMMC ammeter. So इधर मीटर रेसिस्टेंस आएगा. So here comes the shunt resistance. So this is the shunt resistance. So now if you see this is IM, this is RM, this is RSH. So now if you take this as I, this is the ISH. So by adding the shunt component, you can attract the more current. So this RSH is given by one formula, that is Rm by M minus 1, where M is called multiplying factor, that is the full scale current by this. So this is the maximum current to which the range extension should happen to be extended divided by max full scale value of meter current. So this is what we call as multiplying factor. उसको क्या बोलते हैं? उसको multiplying factor बोलते हैं. So this is an important formula, note down कर लो. Next comes RSC. Try to understand, try to mention very clear points these all are. Can anybody tell me, Sujata, can you tell me what is RSC formula? RSC formula. If you see, this is the PMMC ammeter. This is what we call as PMMC ammeter. PMMC ammeter. So next goes the PMMC voltmeter. PMMC voltmeter. So if you see the PMMC voltmeter, so what is the voltmeter range extension? Can anybody tell me? So if you see the PMMC voltmeter, what I am going to get here. So this is my PMMC. So this is my voltmeter reading. This is the RM, and for this I am going to attach a series resistor. This is a series resistor RSC. So now if you take this entire thing and this thing, this is V and this is VM. So V by VM, if you take what is I into RSC plus RM, and this is coming as IM into RM. IM into RM. Very good, excellent. So if you simplify this as M, okay, and this both gets cancelled, both are same. RSC by RM plus 1. So now if you check, RSC by RM is equal to M minus 1. So series resistance is equal to M minus 1 into RM. So very interesting. Sujata, how to remember these formulas? I told you, Ashrita. For shunt ammeter, M minus 1 comes in the bottom, and for series resistor it comes in the series. Please make a note. These all are important formulas. Please note down the formulas. Please note down this information also. Excellent. Yes, good. Please, some extra information also I am giving here. Some extra, have some patience here. बहुत सारा content discuss करना है. See the extra patience here. Generally, what is the material used is manganese. Manganese is a material used because of less temperature coefficient of resistance. No effect due to aging. Alpha is nothing but alpha is called as positive temperature coefficient of resistance. So that is almost 0. So temperature is not going to affect it. 24% copper, 12% magnet, 4% nickel. So ammeters are always connected in series. Internal resistance of ideal ammeter is always 0. These are the key points. Next comes voltmeter. Voltmeter is this, RSC is equal to R into M minus 1. Generally it will be in the kilo ohms range. Internal resistance of ideal voltmeter is infinite. Please note down these points. Internal resistance of ideal voltmeter must be infinity. Internal resistance of the ammeter must be 0. Have you noted these points? Some untapped points I am giving. Please note down these untapped points. Ashrita and Sujata, other my old students. Untapped points also you please note down. अगर पहले आपने सुन रहे हैं तो वहां से भी आप सुन सकते हो. Okay, done. Chalo. Now it is only for DC. So one of the untapped area I want to tell is PMMC as a rectifying instrument. See the applications. Everybody is there. This is very interesting topic I want to convey today. जितने लोग लाइव में हैं मुझे एक बार थम्स अप दिखाए बेटा, कंफर्मेशन कर दीजिए ऑडियो वीडियो सब कुछ क्लियर है. सृष्टि, आई थिंक आर माय ओल्ड स्टूडेंट. अश्रिता माय ओल्ड स्टूडेंट. किरण कुमार पाल ओल्ड स्टूडेंट. तनुकेश्वरन ओल्ड स्टूडेंट्स. एवरीबॉडी इज ओल्ड स्टूडेंट्स. जितने लोग लाइव में देख रहे हैं मुझे एक बार कंफर्मेशन कर दीजिए वॉइस. एवरीबॉडी. यस. सो ध्यान से देखो बेटा इधर क्या हो रहा है. PMMC एप्लीकेशंस रेक्टिफायर टाइप इंस्ट्रूमेंट्स है. रेक्टिफायर टाइप इंस्ट्रूमेंट्स मींस आपको पता होना है. एक हाफ वेव रेक्टिफायर मीटर, अदर वन इज अ फुल वेव रेक्टिफायर मीटर. हाफ वेव रेक्टिफायर मीटर, full wave rectifier meter. So rectifier type instruments can be used for both AC and DC voltages. See, actually speaking, PMMC can measure only DC. But अगर आपने rectify करने के बाद AC measurement करना है, so PMMC directly cannot. So मैं क्या करूंगा, मैं पहले उसको rectify करके AC reading को rectify करके उसके बाद मैं आपको दूंगा. Okay. So rectifier type instruments can be used for both AC and DC voltage and current measurement. These instruments consist of a rectifier and a PMMC instrument. Rectifier and PMMC instrument. समझ में आपको. So now let us see first point. What are the rectifier of instruments? This is the half wave rectifier meter. जिंदा हो, जीवन में हो, please note down. Half wave rectifier meter, full wave rectifier type meter. S सुजाता, दिस टॉपिक इज अनटैप्ड एरिया। आपको पहले मैं डिस्कस नहीं किया था शायद, मे बी इन यूट्यूब क्लासेस यू मे नॉट गेट दिस, सो प्लीज फोकस मोर ऑन दिस पर्टिकुलर टॉपिक। So if you see half wave rectifier instruments, here what happens, we are only going to give diode, one diode. So when you give this type of signal here, what happens after the diode, we are going to only a positive pulse, that to DC. Now this average value is measured by the PMMC, whereas in full wave rectifier diagram, you are going to give a bridge network, two diodes here are forward bias and these two are reverse bias. So they will be having some resistance. So this is a forward bias, so this is a reverse bias. Okay, done. And here comes the PMMC. So if you see the half wave rectifier diagram, so first of all, case 1, input is a sinusoidal wave I have given, then what is the reading of the rectifier type instrument is 2.22 times of the DC voltage, because reading of rectifier is always form factor into VDC. So form factor for the half wave rectifier is 2.22, form factor for the full wave rectifier is 1.11, please remember this. So form factor is 1.11 and here it is 2.22. If it is sinusoidal wave, this is the formula. Please make a note of these points. Untapped area, untapped zone. Rectifier type instrument formula, full form factor into VDC. If it is a sinusoidal, then 2.22 into VDC. If it is a triangular waveform or a sawtooth waveform, then 2.3 into VDC. If input is a square waveform, then 2.3 into VDC. Please note down all these formulas. Important formulas. Done. Next, if we see the full wave rectifier type instruments, in full wave rectifier instruments, form factor will be 1.11. Form factor is 1.11. So sensitivity here, DC la sensitivity is 1.11 into sensitivity of AC. That is, whereas sensitivity there is 2.22. Sensitivity, this is a sensitivity. Okay, this is a sensitivity. Chalo, please make a note of all these values. Sensitivity of DC, voltage of AC, voltage of AC. Square wave la C for full wave rectifier. Specified topics, untapped topics. Noted? Chalo. This is all about rectifier type instruments. Very, very important questions. Whatever the average value comes, that will be measured here. Then so V average is equal to Vm by pi. Here the V average is 2 Vm by pi. So आपको पता है ना ये DC values. चलो, let us go for the next. Next one is a moving iron instrument. So in moving iron instrument, the moving part is this iron disc. So whenever a current is given, this is a coil. This arrangement is a coil arrangement. So coil is like this, one turn, upper turn and lower turn. In between moving iron disc is there. So for moving iron instrument, if you see, this exact picture of moving iron. See here, this is a coil. In this there is a moving iron is there. So when a current travels, this moving iron part is going to make a movement, left and right movement. Or else you can take this picture. So if you see this picture, when a current changes, there is a for incremental current here, there is an incremental flux which makes incremental force, which attracts, which makes incremental change in the inductance. Okay, see here, the deflection torque here is given by formula half I square dl by d theta. So please make a note of this point. So TD deflection torque का formula क्या है? Deflection torque का formula 1/2 I square dl by d theta. ये आप नोट कर लो भैया, मैंने कुछ टाइम नहीं स्पेयर कर रहा हूं, आप ये फॉर्मुलास नोट करने की कोशिश करो. This is the deflection torque and this is a controlling torque. Controlling torque is given by Kc theta. So this is a Kc theta. So now what happens at steady state? I can write at steady state what I can write, deflection torque is equal to controlling torque. So 1/2 I square dl by d theta is equal to Kc theta. So theta is going to come as a function of I square. So please make a note of this point. Please make a note of all these points. So here, if you see the scale is going to be non-uniform scale. So this is the I, this is the T. So the scale I am going to get like this. So for some time I am going to get cramped, for some time I am getting linear, and I am getting spacious like this. So this is what we call crowd, this is what we call linear, this is what we call space. So the scale is non-uniform. Theta is proportional to I square, theta is proportional to V square. So these all are non-uniform scales. Note down. Now here also the range extension here also there, but how to understand the range extension of the moving iron? If you see the moving iron range extension, if you see the moving iron range extension of moving iron, if you check, what happens? The diagram you have to understand, it will be having Rm and Lm. In parallel, it will be having like this. So this is my RM, this is my LM, this is my RSH, this is my LSH. So this is our IM, this is the I, so this is the ISH. This is what range extension of moving iron ammeter. So you should be clear about the diagrams. PMMC contains only resistance, but moving iron contains resistance as well as inductance. Done? Chalo. Now if you see, for DC measurements, this RSH is equal to RM by M minus 1, that I can write it as I by IM minus 1. But for AC measurements, how to do it? So you can write like this: VM is equal to VSH, VM is equal to IM into ZM, VSH is equal to ISH into ZSH. So IM by ISH, I can write it like this: ZSH by ZM. So ZSH means what I can write? Square root of RSH square plus omega LSH square, A square plus B square, divided by this is RM square plus omega LM whole square. So if I am taking RSH square common, it will become 1 plus omega tau, and if I am taking RM common, RM square if I am taking common, it will become like 1 plus omega LM. See what happens here, try to understand. If I take RSH square, let us go step by step. If I take RSH square common, 1 plus omega LSH by RSH whole square, whole divided by RM square, if I take common, that becomes 1 plus omega LM by RM square. So it is a square root. So if I am taking this as IM by ISH, I can take it as RSH out, RM out, the square root of, if the time constant are same, this will be 1 plus omega tau whole square, 1 plus omega time constant of shunt and time constant of the meter. So this is for AC. So please remember, this is a formula for AC measurements. Understood all of you? This is for AC. Further you can simplify, but up to now AC के लिए कुछ questions नहीं आया. Why? Because there is a frequency concept. For a particular frequency आपको current चाहिए बोलो तो आप ऐसे use कर सकते हैं. लेकिन this is for the DC. This is for DC, my dear. Done? Chalo, let us go for advantage and disadvantage. Please note down. What happens here? Moving iron works both on AC as well as DC. Lowest hysteresis error used only for power frequency range, that is okay. Moving iron type wattmeter does not exist. Remember this. We don't have moving iron type wattmeter. We have only dynamometer type wattmeter. ammeter के लिए क्या है? And voltmeter के लिए problem जो आ रहा है, frequency के लिए problem आ रहा है, that problem eliminate करने के लिए. See problem क्या है ना voltmeter का? So moving iron voltmeter का problem ये है. So this is our RM and this is my LM. This is my RM and this is LM, and in series we are going to add a series resistor. So this is my series resistor. So if you see the series resistance, this series resistance you can find out by using the formula V by Vm. So this is my I M, this is my I, so this is the Vm and this is the V. So I can take this as I into Z and this I can take it as I into Zm. So when I take these both are same, gets cancelled. So Z means square root of RSC plus Rm whole square plus omega Lm whole square divided by just Rm square plus omega Lm whole square. Please make note. Please make a note of these points. नोट कर दिया? चलो. Now, next comes the dynamometer. Next instrument is dynamometer type wattmeter. So if you see the electrodynamometer type instrument, it is called as EMMC. So from the PMMC and from the moving iron combination we are taking. So this is a PMMC, this is a MI, moving iron. So moving iron is type electromagnetic type, right? This is electromagnet type. So from this I am taking the EM and from this I am taking MC. So it becomes as EMMC. Moving iron instrument is also called as EMMC. So the interesting thing here is we are having two fixed coils, okay, and one moving coil. Between the two fixed coils, one moving coil is suspended so that when a current travels, it acts like a magnet, it also acts like a magnet. Between the two magnets, one moving coil is suspended so that there is a mutual inductance phenomenon. So because of that inductance phenomenon, there is a reflection that makes the pointer to move. The amount of deflection happening here, that is proportional to change in mutual inductance of this setup. So that's the reason why if you see the formula of moving iron instrument, the deflection torque of the moving iron instrument is given by I square dm by d theta, okay, and the controlling torque is given by kc theta, okay. At steady state, so if you see at steady state what happens, deflection torque is equal to controlling torque. So this is I square dm by d theta, I can take it as kc theta. So theta is coming proportional to I square, theta is coming proportional to v square. This is dynamometer ammeter non-linear, this is dynamometer ammeter, this is dynamometer voltmeter. The scale is non-uniform, this scale is non-uniform, this scale is also non-uniform. Note. But if we go for the adjustment, basically deflection torque, if you do some adjustment, the deflection torque is going to come like this, VPC, which is VPC ICC cos phi. What I'm going to get? VPC ICC cos phi dm by d theta. So this is a deflection torque. Finally, it follows the square law, I square dm by theta square law. So the advantages are, it is suitable for both AC, DC, non-linear scale, and the most important thing is it is useful for power measurement. Okay. All of you ready? Now listen carefully here. So see this, AC power. Please make a note of this AC power. गुड इवनिंग क्लास चालू है भाई, आप नोट कर लो. सर, आई हैव अ डाउट हाउ टू कैलकुलेट डिविजन्स व्हाइल टेकिंग ए सर्टेन रीडिंग. व्हाट डिविजन्स यार, व्हाट डिविजन्स यू मीन? सी हियर, when I are taking the AC power measurement, P average is equal to VRMS ICC cosine angle. Always remember, if you are taking the angle between this VPC and ICC, okay, so you have to take that angle, particular angle between them. So average power is given by formula pressure coil voltage, current coil current, and the angle between them, so that is VPC versus ICC. Is asked, if suppose a question is asked, V of t is given like this, a DC component is given and a AC component with sine of omega t, sine 2 omega t, and current is also a DC component and AC component. But when you are taking this now, you have to consider only the average of these instantaneous terms. So if you are taking this V1 by 2, I1 by 2, so you have to take the angle between these two. Okay. Similarly, when you are taking V2 and I2, you have to take the angle between these two. So we are going to get certain questions like that. So DC power is V0 into I0. So this is Vm by 2, Im by 2, and the angle between them, plus Vm by 2, Im by 2, and again angle between them. So fundamentals you have to consider. First harmonic, second harmonic you have to consider. In numerical problem, this is very interesting. That's why I am telling. Now, so some of the important things here I want to explain you. LC connection and MC connection. So if you see the LC connection and MC connection of the dynamometer, so this is your current coil. Current coil is somewhat thicky like this. So this is a current coil. So if you see the current coil, this is the current coil. Okay, and here comes your load. ध्यान से सुनो बेटा, थोड़ा attention में सुनो. So this is the load. Okay, and here comes your pressure coil. So how your pressure coil is going to be connected? How your pressure coil is going to be connected? So this is a pressure coil and this is the resistance of the pressure coil. So if you see now, so this is the resistance of the pressure coil, this is the VPC across this, and where you are going to connect this? Where you are going to connect this? This is very important, my dear. Suppose you are connecting here, this is the mains connection. So this is the mains connection. If you are connecting at the mains now, so single phase, it is connected at the main side. So this is MC connection. It is connected at the main side. So it is called MC connection. MC connection. जैसे 100 divisions in 50 volts in voltmeter and wattmeter. Okay, listen. What he was asking, if you are taking divisions like this, yeah, you are asking some question. 50 volts. So 0 to 50 volts. You are asking some question, right? 0 to 50 volts. So this 0 to 50 volts divided into 100 divisions. इसका मतलब है, this is split into divisions. Division number 1, division number 2, division number 3, division number 4, like that 100 divisions. So 100 divisions are contributing to 50 volts. 100 divisions are contributing to 50 volts. Then one division contribute how much? 5 volts. Sorry, 50 by 100. So one division contributes 0.5 volts. One division contributes 0.5 volts. So this is 0.5. Next comes 0.5 plus 0.5, 1. This is 1, 1.5, 2, 2.5, like that. So 0.5 into 100, 50 volts. So now if you take one division, this is one division. Now one division corresponds to 0 to 0.5 volts. This is a one division. Now from this, 1 by 10th of a division. 1 by 10th of a division. 1 by 10th of a division or 1 by 5th of a division. So 1 by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what we call as 1 by 10th of a division. So 1 by 10th of a division, 1 by 10 into 0.5. So that becomes 5 by 100. So that will become as 0.05. That means the minimum increment is 0.05 volts. Is your doubt is clear now? Divisions concept is clear? Yes, अर्जुन यादव, मैंने बहुत सारा फैंस एसोसिएशन है, मुझे पता है. Crystal clear, sir? Thank you. Thank you. Thank you. Now this is what we call as MC connection, my dear. So I was talking about this MC connection actually. This is one type of connection. The other connection is also important. Suppose if I am taking this other connection. So this is the other connection. So if you see here other connection, this is my load. This is the resistance of the pressure coil. But this time this is connected here at this side. That means at the load side it is connected. This is the load. So now if you see, if we check now, this is a single phase mains. Okay, so this is my current coil, this is my pressure coil. So if you see the voltage here, this voltage is VL, this current is I, and this current is ICC, current passing. This current passing ICC split into two parts here, IPC and IL. Are you following, my dear? ध्यान से सुनो. This is a current I. Now it is split into two parts. This is ICC and this is IPC. Current passing through current coil and current passing through load, both are same here. So this is the VL. This side pressure coil is connected this side, it's a main side, so that's why it's called MC connection. So pressure coil is connected this side, so that is what we call as LC connection. LC connection. So please note down these two pictures. MC connection, LC connection. Sujata, are you there? Arjun Yadav, are you there? Ashrita Borinji, are you there? Gate fans, are you there? So please make a note of the connections. Okay, okay. Okay, okay. Please make a note of this. I square RCC. So error should be less. So we are expecting the error to be less. See, in MC connection, true value formula is this VLIL cos phi. And measurement value is true value plus power consumed by the current coil. Power consumed by the current coil is I square R. Why? Because if you see this picture, in the picture, in addition to this power consumed by this load, this power also comes into picture. So I square RCC will come. Okay. So I am expecting error to be less. Error to be less means this I square R to be less. That means ICC must be less. ICC must be less means ICC equal to IL. ICC equal to IL, so IL also must be less. So that means MC connection is best suitable for where? MC connection suitable for smaller load currents second, smaller load currents are possible for highly resistive loads. Highly resistive loads. Please note down this, my dear. So with this analysis, thank you, 𝐂𝐸𝐬𝐿. Note down. Similarly, we'll go for LC connection. If you go for LC connection, load side connected. This is load side connected. Pressure coil is connected load side. This is a moving coil. This moving coil is connected to the main side, so it is called main side connected. It is called main side connected. This is load side connected. So now if you check here, in LC connection, the true value is same, that is VPC or VLIL cos phi. Power consumed by the load is always this. Measurement value क्या है? If we see the measurement value in the picture, so this is the measurement value. It comes from this power and this power. So in addition to the true value, we are going to get power consumed by the pressure coil. Okay. So now if I am going power consumed by the pressure coil, if you check here, this is a power consumed by the pressure coil, that is this. So the voltage across this is VPC. So power is equal to I square R. I square R, I means V by R. So V square by RPC. So measurement value minus true value is equal to V square by RPC. So now if you are expecting the error is equal to V square by RPC, I don't suggest to start a new subject in this last week. साई किरण रेड्डी, जो सब्जेक्ट्स आपने पढ़ चुका है वो सब्जेक्ट्स पर आईएन का जो क्वेश्चंस है वो प्रैक्टिस कर लो. मैं ये बात बोलना चाहता हूँ अभी जस्ट यू आर हैविंग ओनली 1 वीक अहेड. ये 1 वीक में 1 वीक के पहले आपने नया सब्जेक्ट शुरुआत करना अच्छा नहीं है. जो आपने 7 सब्जेक्ट्स पढ़ चुका है ना, वो 7 सब्जेक्ट्स में एक्यूरेसी के लिए कुछ क्वेश्चंस प्रैक्टिस कर लो. अगर आपने गेट इंस्ट्रूमेंटेशन का पेपर भी लिखना चाहते हो, गेट मेजरमेंट्स ऑफ इंस्ट्रूमेंटेशन सॉल्व कर लो, गेट सिग्नल सॉल्व कर लो. जो भी कॉमन सब्जेक्ट्स है ना, वो कॉमन सब्जेक्ट्स का इलेक्ट्रिकल में और इंस्ट्रूमेंटेशन में जो कॉमन सब्जेक्ट्स है वो सॉल्व करने की जाओ. ओके, आई डोंट सजेस्ट साई किरण रेड्डी टू स्टार्ट ए न्यू सब्जेक्ट. अच्छा नहीं है, अभी स्टार्ट करना अच्छा नहीं है. इट इज नॉट एट ऑल करेक्ट. मैं टाइम पास नहीं करना चाहता हूं, मैं ग्राउंड फैक्ट बोलना चाहता हूं. अगर आपका जो 7 सब्जेक्ट्स में आपको कॉन्फिडेंस है वो कॉन्फिडेंस ऐसे ही रख दो. अभी नया सब्जेक्ट शुरुआत करके लास्ट मिनट में क्या करेगा अगर कुछ अच्छा नहीं समझ में आए तो. सो जो भी 7 सब्जेक्ट्स में आपको ग्रिप है ना, वो क्वेश्चन सॉल्व करते जाओ. सो एरर शुड बी लेस ना. एरर शुड बी लेस मीन्स VPC should be less. That means IPC should be less. IPC, if you observe closely here in this picture, IPC should be less. So this is the IPC. IPC should be less means IL should be more. Why? Because ICC is equal to divide as IPC plus IL. मेरे दोस्तों, अगर आपने इसको कम करना चाहते हो, इसको कम करना चाहते हो, then it should be high. So IL should be more. This is one of the important question, my dear. So what I can write here, MC connection or LC connection best suitable for, LC connection suits for what? Larger, IPC should be less means IL should be more. Larger load currents, इसका मतलब ये है small resistive loads. नोट डाउन. सो इतना सारा कंटेक्स्ट है इसमें. यस सश्रिता, इफ आर इलेक्ट्रिकल देन यू राइट ओनली इलेक्ट्रिकल पेपर ओनली. इंस्ट्रूमेंटेशन में लिखने के चांसेस लिखो, लेकिन जो डोंट टच द इंस्ट्रूमेंट सब्जेक्ट इन दिस लास्ट मोमेंट. चलो नोट कर दिया. नाउ सी हियर, आई एम जस्ट गिविंग सम मोर फॉर्मूलास. दीस आर सम एक्स्ट्रा फॉर्मूलास. So I told you, in MC connection error is this, in LC connection error is this. To get equal error you have to get this. Okay, this is I square RCC, this is I square by RPC. This I square by RPC also can be written as V square by RPC. This also can be written as I square RCC. Okay. एंड वन टिपिकल क्वेश्चन, हमने प्रेशर कॉइल को प्योर रेसिस्टिव माना चाहते हैं, लेकिन प्रेशर कॉइल कैन नॉट बी प्योर रेसिस्टिव. इट इज हैविंग सम इंडक्टेंस इफेक्ट. सो ड्यू टू द इंडक्टेंस इफेक्ट आल्सो वी हैव ए एरर. सो दैट एरर इज दिस VI cos phi tan beta. Okay, so that is the error due to the pressure coil inductance. Please note down that. See the readings. Reading of the meter is PI cos of phi minus beta into cos beta. So this is somewhat typical. Correction factor is cos phi by cos of minus phi minus beta. So this a true value is this V into I cos phi. Measurement value is V of cos phi minus beta. See, what I mean to say is, true value is always Vi cos phi, but if we consider the pressure coil inductance, we are not getting this phi as it is, we are getting phi minus beta into cos beta. This cos beta is the angle due to pressure coil inductance. Yes, yes my dear. Cos beta is due to the pressure coil inductance effect, that is the error angle due to pressure coil inductance. Okay, so if you take the total error, percentage error, so this is the measurement value, so percentage error is going to come as plus or minus tan phi tan beta into 100. Phi is the angle between pressure coil voltage and current coil current. Beta is the angle between pressure coil inductance. Important. Okay. So if the load is lagging type, then the formula is this. If the lagging load is means inductance. For leading load, this is a context. This is a leading actually. This is for lagging, this is for leading. This is for lead. Okay. So don't confuse these formulas, somewhat typical formulas. Very rarely you can expect this question from the error due to pressure coil inductance. Please make a note of these formulas. This is minus or plus or minus. Chalo. Next comes 2 wattmeter method. So as per the Blondel's theorem, when you are measuring the 3-phase power measurement, if you are going for the 3-phase power measurement, in n-phase system, one phase is common to other, number of wattmeters required is n-1. For a 3-phase power measurement, we require 2 wattmeters. So first power 1, 3, root 3 VPH high-weightage cos of 30 minus 5, P2 is equal to cos of 30 plus 5. So this is 3-phase power P1 plus P2, you are going to get root 3 VLIL cos phi, 3 VPH high-weightage cos phi. So instead of doing all these things, I will tell you the technique how to remember this. In the 2 wattmeter method, I will take you the best techniques to remember. जिंदा हो सब लोग, जीवन में हो, किधर भी मत जाना, ऐसे ही रहो बैठ के. चलो, so how to use the 3-phase power measurement? ध्यान से देखो. I am taking 2 wattmeter method. This is my three phases. R phase, this is a neutral, so this is a R, so this is a Y, this is a P. So 3-phase power measurement के लिए मैं क्या कर रहा हूँ, इधर मैं keeping current coil, so this is this, and pressure coil is this. And another current coil I am keeping here, and pressure coil I am keeping here. So this is wattmeter 1, this is wattmeter 2. Please note down. So now if you see W1, W2, so this is a voltage. If you see, this voltage is VRB, and this voltage is VYB. Okay, so if I am going for W1, so W1 is equal to, what is the voltmeter 1 reading? That is VRB into IR, cosine angle between VRB and IR W2 reading is this VYB and IY. VYB and IY, cosine angle between VYB and IY. How many of you are comfortable with the phasors? आपको phasors clearly पता होना है, otherwise you cannot do this. Without phasor you are not electrical student. This is VRN, this is VYN, this is VBN. So this will be VRN, this will be VYN, this is the VBN, this is the IRN phase currents, IRN, IYN, IBN. So this is IRN, this is IYN, this is IBN, this angle is phi. So मुझे अभी क्या चाहिए? स्टार मॉडल है ना, VRB चाहिए. So VRB I can write it as VRN minus VBN. That means I can write it as VRN plus of minus VBN. So this VBN is negative side. If you draw, it will come like this. Okay, so this is minus VBN. So now if I am taking like this, okay, so now if I am going for this, phasors लिखना एक आर्ट है, आर्टिस्ट बनाना है, అదొక ఆర్ట్, అందుకే ఆర్టిస్ట్ ని జైల్లో వేసేస్తున్నారు మమ్మల్ని. ఓకే, సో దిస్ ఈస్ మై phasor. So this is my phasor, this is VRB. Now this angle IRN is nothing but IR, line current is equal to phase current in the models. VRN, VYN, VBN, these are the phase voltages. IRN, IYN, IBN, these are the phase currents. VRB, VRY, VYB, VBR, these are line voltages. IR, IY, IB, these are line currents. So for a star model, line voltage is equal to √3 times of phase voltage, line current is equal to phase currents. This is for star model. Now from this I can take this angle as how much? I need the angle between these two. So if you take this total angle is 120, if you cut it, it will become 60, 60. Then if you cut it, it will become 30. So this angle is 30 minus, am I right? 30 minus 5. Similarly, if you take VYB, that is VYN minus VBN, that means I can write VYN plus of minus VBN. So the resultant will be these two. So this is my VYB. Okay. Now this angle I want to check. So this angle is 5, this angle is 30. So this total angle will be 30 plus 5. 30 plus 5. Okay, so now if I'm writing the readings, W1 reading is VL IL cos 30 minus 5. W2 reading is VL IL cos 30 plus 5. All of you noted down? So this I can take it as equation 1 and equation 2. Please note down. So now I am taking W1 minus W2. Can you tell me someone W1 minus W2 क्या हो रहा है? W1 plus W2 क्या हो रहा है? Please बताओ यार, जल्दी बताओ ये दोनों करके. ओके लाइन में है ना, लाइन में। सो ध्यान से देखो, W1 प्लस W2 इज √3 VL IL cos phi आ रहा है। ओके ओके, चार्जिंग चल रहे, ओके नो प्रॉब्लम। सो √3 VL IL cos phi, इट्स अ स्टार मॉडल ना। फॉर स्टार मॉडल VL इज इक्वल टू √3 VPH, IL is equal to IPH cos phi. √3 is 3, so 3 VPH IPH cos phi. 3 VPH IPH cos phi. So W1 plus W2 is this. Now observe, GATE 2026 आपने जो क्वेश्चन पूछ रहे आपको मिला. So with 2 wattmeters, just with 2 wattmeters we are getting the 3 phase power ना. So 1 wattmeter मुनाफा, 1 wattmeter connection is not required. The number of coils will be reduced, number of cost also reduced, everything is reduced, and in addition to that you are getting the reactive power also. If you write VL is equal to √3 VPH, IL is equal to IPH, and if you write √3 multiply, so 3 VPH IPH sin phi, that is the reactive power. So you are getting the average power and you are also getting reactive power. So reactive power kaise? Sujata, are you there? Ashrita, are you there? So if you see this, W1 minus W2 is equal to, you are getting VL IL sin phi na. So if I am writing VL is equal to √3 VPH, IL is equal to IPH sin phi है ना, √3 से मल्टीप्लाई करो दोनों साइड, so W1 plus W2 आ गया, and this is VPH √3 3 हो गया, so which is nothing but 3 phase reactive power हो गया ना, 3 VPH IPH sin phi. So this is reactive power. So advantage क्या है, मुझे 1 वाटमीटर सेव हो रहा है, कनेक्शंस कम हो गया, बजट भी कम हो गया, मुझे एवरेज पावर मिल रहा है, इसके साथ साथ मुझे रिएक्टिव पावर भी मिल रहा है। देखो ये Q है ना, समझ में आपको, दिस इज Q, दिस इज P. गॉट इट माय डियर? दैट्स इट. इफ यू रिमेंबर दिस बॉक्सेस, योर जर्नी इज डन, अश्रिता जी. सो इक्वेशन नंबर 1, इक्वेशन नंबर 2, इक्वेशन नंबर 3, इक्वेशन नंबर 4. Getting? Chalo. So now there is another formula for power factor that also you try to note down. So that is a formula which is coming like this. So tan phi. So please note all these formulas. So tan phi is another formula, √3 W1 minus W2 by W1 plus W2. Please note down this formula. W1 is equal to VL IL cos of 30 minus phi. W2 is equal to VL IL cos of 30 plus phi. Please note down the box. तनुकेश्वरवन्नी, आप एक ही कमेंट लिखता है लेकिन समझ में आ रहा है नहीं समझ में, कुछ भी नहीं लिखते. हाँ, you don't give affirmative statements, always getting unaffirmative statements. Yes. Okay, done. Chalo. Done? Any doubts? Any doubts? Hello. Now these are the major formulas. So this was the Brodler's theorem. So if you are using n phase and n plus 1 wire, for each wattmeter, 1 wattmeter, unbalanced both the n wattmeters are required. N phase, n wire, n minus 1 wattmeters are required. So this is all story here. अगर आपने separate neutral line use किया, you require 3 wattmeters. अगर आपने separate neutral line नहीं use कर दिया, 2 wattmeters. That's enough. Okay, done? So with this we have done the basic questions of power. Concepts were clear. Now let us go for the energy meter. एनर्जी के लिए कुछ भी नहीं है. एनर्जी के लिए जो हमारा important formulas only you have to understand. So just please note down the important formulas for energy meter. In energy meter diagram, energy meter construction, they are not important, just only the formula. The number of revolutions happening, that is N, is directly proportional to the energy consumed. N is proportional to the energy consumed. So please note down just. Energy meter constant K is given by number of revolutions made by the disk by energy recorded. So energy, see, always remember like this. N is proportional to the energy. So if I remove the proportionality, K into energy. K is equal to N by energy. Energy means power into time. So please note down. So units are energy meter units. Energy meter units. 1 unit is equal to 1 kilowatt hour. 1 kilowatt hour. So this is what the energy unit, 1 kilowatt hour. The number of revolutions happening is directly proportional to energy. If I remove the proportionality, I am getting K. So K is equal to N by E, revolutions per kilowatt hour. Energy meter constant is equal to K, number of revolutions by this. Okay. So next comes the electronic measurements में जाएंगे. If you go for electronic measurements, CRO is one of the important topic. Cathode ray oscilloscope पर, if you see the cathode ray oscilloscope, the major context of cathode ray oscilloscope is so we are having 3 sets of plates. One is the focusing anode. See, cathode ray oscilloscope में theoretical questions कुछ भी नहीं आएगा. Majorly you have to focus on the Lee patterns. Okay. So in the next session, tomorrow session, I will be covering this electronic measurements part. Okay. आज के लिए बस करूँगा मैं. CRO part, everything we will do tomorrow. Okay. Enough for today. If you have any doubts, let me know. Electronic measurements part I will convey tomorrow. Tomorrow we are having another session. In that session we'll cover with some beautiful questions also. రేపు చెప్పుకుందాంలే అమ్మా. ఓకే, బిట్ చేసుకుంటే రేపు చెప్పుకుందాం.